So yesterday we kind of refreshed our memories on simplifying radicals. Today we're going to learn something new, but it's really not new for y'all because of the whole big screw up yesterday. But so you'll kind of get a heads up. Okay, so how do we know if variables raised to powers represent a good square root? If they're even. So one way to think about this, guys, so we have number one, right? So we're going to split it into two sections. We're going to split it into good and bad. We have the good side and we have the bad side. So we'll go 80 first. What is the good square root side of 80? 16, because 16 times 5 is 80, right? So we go 16. Oh, that's not the way I want it to go. That's not normal. Okay, so we do 16 and we do 5, right? Because 16 times 5 is 80. Now here's one way to think about it. A different way than I taught yesterday. So we have x to the fifth, right? How many x's would we have to take away from x to the fifth to make it even? Just one, right? If you take away 1 from x to the fifth, it becomes x to the fourth, which is a good square root. We have to put the one we took away over on the right side. So one way you can think about it is how many do I have to take away in order for it to be even? Yeah, it'll always be 1. Or none, right? What about y to the first? All bad. Z to the sixth, all good. And then we're on our merry way, right? So we still have to find the square root of all these things. So square root of 16, 4, square root of x to the fourth, x squared, square root of z to the sixth, t to the third, and then root 5, x, y, and that's your answer. Right? Any questions on that? Okay, I'm going to do this. I'm going to split. Andrew, give me the good split of 64, a to the 4th, b to the 7th, c to the 11th.
It's 64, a to the 4th, b to the 6th, c to the 9th.
Very good. Leaving b and c, right? And then we come down, so we have -3. Now, I don't know, how many of y'all just go ahead and do -3 times 8 at this point? Okay, that's what I do. If you want to rewrite it, you're welcome to write -3 times 8. But I would just think -3 times 8 is -24, a squared, b to the third, c to the fifth, root b, c. Okay? Right? Let's see. Kiana, give me good, bad. Continuing. Give me the entire good side. 100. Okay. Q squared r to the 10th, leaving 2 p, we are q over on the bad side, right? 2 times 10, 20, q r to the 5th, root 2pq. Hate q's. I don't know why I keep making Tristan. Because I think it's a 9. Dude, I'm just telling you the way it works with me. Usually I'll do this. I always make it a capital, I guess. Doesn't really matter. What's the rule on adding and subtracting radicals? How do we know when we can add or subtract them? When the roots are the same, right? So remember, the way I want you to think about this is I want you to do this guy, and then I want you to do this guy, then I want you to reset it up as an addition problem. So we start with -4, root 75. It splits into -4, root 25, root 3, which is -4 times 5, so -20, root 3 on the left-hand side. We have 3 root 48. What do we know is going to be the bad root? It pretty much has to be because on the other side it is. So 3, 16, 3 times 4 is 12. Yes, 3. And so then at the end, we basically have this guy plus this guy. We end up with -8 root 3. This should be getting to a point where you're just like knocking it out. And let's see. Kaylee, what did you get for number 5, all the way down to the bottom?
I got 2 and root 6.
2 root 6. Anybody get anything different other than 2 root 6? Cool. Any questions on simplifying radicals? You sure? All right. Notes. We are going to do what's called rationalizing the denominator. We talked a little bit about this yesterday, but because I'm recording, I'm going to pretend we didn't do it at all. Here's the way it works. In order to be a simplified answer, you cannot ever have a square root in the denominator. In order to have a simplified answer, you can't have a square root in the denominator. But you're not just allowed to go off and change the value of a number. It's against math law. It's a felony. You go to prison. Very bad. So the only way to not change the value of a number is to multiply it essentially by what? 1. If you multiply any number by 1, it won't change its value. So what we end up having to do is take our little unsimplified version and multiply it times something whose value is 1, but will remove the square root from the denominator. And in this case, it would be square root 13 over square root 13. And the reason that it works is because any number, any root, when multiplied by itself, actually gets you the number inside the root. If you doubt it, you can just do the math. Because root 5 times root 5 is root 25, and the square root of 25 is 5. And that works with any number. It works with any number. The square root of 380 times the square root of 380. It's amazing how many kids will actually start doing the math on that. It cracks me up. Yeah, don't break the calculator system. Okay, so when we're doing the math, if you remember back to multiplying fractions, which most of you, have some issue with, top times top and bottom times bottom. So we end up with 2 times the square root of 13 over the square root of 13 times the square root of 13, which is 13. And then you take one last look and make sure that your numbers, your whole numbers, your coefficients cannot be simplified. In this case, they cannot. That is your answer. Now, here's an interesting thing. If you type in 2 divided by the square root of 13 in your calculator and hit enter, it will give you a decimal, a number. If you then type in 2 times the square root of 13 divided by 13 and you hit enter, it will give you the exact same number. Because the value of the two numbers is the same. Okay? So it's one way to check it. So, Cardi, what should I multiply 1 over root 17 by? Root 17 over root 17. Top times top. Root 17. Bottom times bottom. 17. No simplifying necessary, you're done. You try number 3. Please, Andrew. Wake up. So again, remember, the only thing you have to get rid of is the root. Don't multiply it times 5 root 3 over 5 root 3. That's unnecessary work. Just get rid of the square root. Times the root 3 over the root 3. Right? What's 27 times the square root of 3? Oh, it's 27 times the square root of 3. Okay? Now this one, what's root 3 times root 3? 3. 3 times 5? 15. But it can be simplified because 27 over 15 can be simplified. Now, does anybody remember before if you're going to be lazy and pretend like if you were going to go to high school and pretend you were from like, I don't know, Fabian, how could you simplify 27 over 15 without using your brain? Pardon? How can you do it using a calculator? Math, enter, enter. You can type in 27 over 15, do math, enter, and the calculator will think for you. But again, that's not the way we play. So, both divided by 3, let's see, 27 divided by 3 is 9. 9 over 5, so our simplified answer is 9 root 3 over 5. And that cannot be simplified. Any questions? Okay, y'all do 5, I'll do 4. I know, that's why I chose it this way. Go all of them?
Yeah, I did all
Oh,
I did
Lord,
that.
good. I'm sorry, it was an accident. Yeah, don't bully. Ooh, these are good ones. This so you have root 21 over 3. Isn't it funny though that this is the same value as that though? I think I always found that coming. Okay, the last one is root 5 over root 5. So we end up with 15 times the square root of 5 on the top. On the bottom, we have 3 times root 5, root 5, root 5, root 5, root 5. 5 times 3 is 15. Ooh, it's just root 5. Any questions on that? Who would be texting me in school? Oh. Any questions on that? All right, last thing. Binomials. Oh, stop it, you big reps. How do we multiply binomials? Brady, how do we multiply binomials?
The first time, okay, the FOIL.
Oh, FOIL method, look at that. Brady, remember. You do not use the Potts method. Stop it. Take the training wheels off your bicycles and ride like a big boy. Here we go. FOIL, F-O-I-L. It keeps food fresh for days. It can also clean up your grill. Okay, here we go. First, 3 times 2 is 6, right? Oh, for outside, 3 times root 7 is 3 root 7. Inside, what's negative 5 root 7 times 2? Negative 10 root 7. And L for last is minus, what is 5 root 7 times root 7? Well, root 7 times root 7, 7. So 5 times 7, 35. Now I want to pause and make sure everyone kind of kept up with that. Here's the thing, my little genius children. This is where going too fast is going to absolutely knock the wheels off of the bus. So slow down and make sure you're connecting all the dots. Now, is that a simplified expression? No, because we have like terms. So here we go. 6 minus 35 is negative 29. Positive 3 root 7 minus 10 root 7 is minus 7 root 7. And that is your final answer. Now the obvious question is, could I have written negative 7 root 7 minus 29? Can I? What do we learn about the order of sentences? If I have 3 minus 2x, it's the same as what? Negative 2x plus 3. Remember, the sign belongs to the number before it. I don't care. On a standardized test, it's really going to be determined by who makes your test, right? Looking at your answer choices. So just know, I'm grading it and I'm good either way. So why don't you try 8 for me, please? Once you take your time, I want to see the FOIL step. I want to see the unsimplified step so that I can see where you're making mistakes, if you are making mistakes. Put your name in the stand. 5 bonus points on the geometry test. If you can name this band without the benefit of an electronic device, just because of your musical prowess. Here, I'll let everyone listen. Hold. One. Very, very interesting. On one of the top worldwide bands in existence. Still touring. No. Oh my gosh, no. Bring it pop. I can't really tell you what it starts with because it gives it away. Is it a bird? No. You too. This is you too.
It's you too.
Thank you. Can you give me the first 2 letters of the band name? Well, it's you. There's not really a second letter. So there's that.
You too.
Okay?
No, it's
It has never been spelled out ever.
no, but I need it.
My wife would have just thrown something like that. Okay, here we go. Foil. 4 times 5 is 20. Outside. 4 times root 3 is plus 4 root 3. Inside. Minus 5 root 3. And last, which is the one that typically gets kids, minus 3. Be careful about that. Now we combine like terms. We have 20 minus 3, 17. Minus 1 root 3. If you wrote 17 minus root 3, that's perfectly acceptable as well. And I think I told you guys yesterday, you don't have to write a 1 in front of root. I don't count it wrong. I would never count it wrong because mathematically it's correct. However, you may have teachers in high school that will actually count off of that. Look, I can't control their softness. Okay, so any questions on that? So I'm going to roll through. Y'all do 10, I'll do 9. And we'll meet at the end of the fork in the road. Y'all do 10, I do 9. Y'all do 10, I do 9. 10, 10. What was that? There's a cheer that goes with that, right? Y'all say, sorry, I don't know. I am. Oh, y'all say console, I say Cowboys, console. That's what I knew it. I knew it was a cheer. I knew it. 10. Okay, Anna. No, it's not countdown. Two.
This is math class, that's why.
Yeah, that's why.
You want to be in a different math class?
See if you got that. If you didn't, I want you to go back up to that next line up and identify where you went wrong or where I went wrong, because, you know, that has happened like 3 times in my life. I've been wrong. So, any questions on this?
No.
This is simplifying radicals day 2. After today, we go into Pythagorean theorem, okay? Where you would use this type of thing, okay?
Wait, what?
Pythagorean theorem.
Oh, I know what.
You have to do Pythagorean theorem with that stuff.
Does anyone have a differences with that?
Okay? Does anyone have what?
I'll just tell Josh.
All right, last word. Where does that go?
I'll just tell Josh.
There are suckers, so stick her up.